Hello, and welcome to another episode of AWS Tech Tales. I'm your host, Matt Burke.
And I am your co-host, Samara Reaño. Welcome back, everyone.
And Zamara, welcome back.
Oh,
Zamara's
thank
been
you.
out for a while. Brooke's been subbing in, so I'm really happy to have Zamara back on the show. So if you've been watching Tech Tales and you missed Zamara, please leave us a little chat, say hi, and welcome her back. Oh, Sam, welcome back. Hey,
Hi,
Sam.
Sam.
Hey, Erie Edits. Oh, all our friends are already back on stream. That's awesome.
Yes, I see that we still have our freaking audience coming in again. So yes, I was out. I totally missed all of you, but I heard everything went great with Brooke, so I truly appreciate her filling in for me. I can't wait to actually go through all the episodes and catch up with everything that you guys have been having fun with in the past few weeks.
Speaking of catching up on episodes, Amara was just asking me right before we went live, what's going on with our page? If you've been a long time listener, I guess watcher, we've had our own page for a while on what was the community.aws, but now that's transitioned to Builder Hub. So I promise that we will get a new page up and running soon, and we'll share that with you in a future episode. Arietta says Brooke did a great job. I'll
Yes,
let
she
her
did.
know.
She sure did.
She went and she's on break now too. She's taking a well-deserved vacation. So I will let her know when she gets back. Or maybe she'll tune into this episode on the replay and realize as well. So what we've been diving into, Zamara, while you've been out, is we've been diving into the wonders of Q Developer and the wonders of Q CLI, and really like what AI can do for you in your IDE or in your CLI. And this all just started when we were troubleshooting some CloudFormation stuff, and Brooke said, "Oh, why don't we ask Q to help us?" And I realized I didn't know how to use QCLI yet, and and chat was helping me out. And then once we did start to use it in some of the episodes, we're realizing how powerful it is and how easy it is to use, as long as you know the things that you want to do. And so today, I figured now that you're back, I can do something that you probably have been working with, our customers and our chat maybe have been working with, which is doing some resiliency testing. And yeah, that's where we're starting today.
Yeah, that's awesome to hear. I am definitely looking forward to it. I mean, I know that this is a very hot topic right now. Everybody's kind of like diving in and trying to see how they can maximize their productivity. So this is, I think, a great way to showcase just that. So I'm excited, Matt.
Because typically, like, what I like about Q, and chat, let me know if you've used Q Developer yet since our previous episodes, Sam or Erie, if you've been playing around. But what I like about it is like when I'm using Gen AI for like writing, it's like kind of weird to me because I'm like, I know what I need to write. If I rewrite it, it's not going to sound like me. But when I use it for stuff like this, I oftentimes know what the outcome should be or what I'm trying to build, but I might not know what clicks I need to get there. So rather than me looking up documentation, I can just ask Q to do it, and then it's been doing pretty well. So we'll see how it performs today.
It's more of like a live guidance rather than you kind of going through all these documents to get to where you want. So that's like, I guess, like the magical aspect of it.
Yeah, exactly. So I'm going to bring up our little architecture of what we're going to
let's jump right in
today. Because what we're going to try to do, again, what we do in Tech Tales is we talk about real life customer issues and what you can do to solve them. And typically a customer, I don't want to say issue, but like typically when customers ask us as TAMs what they can do to improve their environments, a lot of the times we've been talking about resiliency. And to me, resiliency means just beyond like normal high availability or DR testing. It really is about testing your assumptions of what your application can do. So I'm going to pull up our little application on the screen. This is a voting application that we're going to be testing with. It's voting on specific restaurants, which restaurants that you like. And I'll tell you what the options are, and you can let me know in the chat what you like. But it's just a EKS app. So it's running in containers. And we've got our clusters running across two different regions. You got US 1, US West 2. I've got a voting app container image. We're not going to do much messing with our private registries, but just so you know, we're copying that image cross region. And then we've got a DynamoDB global table here that has our voting app table in it. So it's keeping our votes tabulated.
Yeah, pretty much like the tallies of it. Okay.
So that's where we started. I did some pre-prepping before the show, but I will show folks what we've got cooking here in our environment, what this app looks like. So let me get all my windows straightened out. So Zamar, so far so good. Any questions that you have, or let's see, maybe the chat has on
yeah, any questions? I mean, like we always say, drop any questions, or if you need clarifications on any of the steps or things that we're doing today here with Matt, feel free to drop them in the chat, and then I'll bring them forward, and we can walk through them. No, I don't have any questions so far. I think it's pretty straightforward. So yeah, I'm good.
So right now I'm just saying, hey, can you get me some of the votes? Let me actually make sure that we've got our voting app working properly. So I'm just going to get some votes in there into the system. Oh, hold on. So let me make sure I have the right. Friendly Crane saying resilience testing. Yes, welcome. So I have the right. Let's see, where's my deployment here? Hold on. I got a lot of different things open right now. Of course, when I pre-staged everything, what I want to do is make sure I've got my load balancer. Okay, I'm gonna miss that step. So now what I should get is, there we go. Perfect. Okay. So what do we have here? Iriad is saying, when it comes to AI, I'm in the absorption phase, meaning I like to see what it can do, but I don't have much of a use case that's given me the impetus to really dig in. Well, I hope today is one of those where you can kind of see what it can do. So we got this app. Again, what we're going to do, the kind of flow of the show today is I'm going to do all this stuff manually through Fault Injection Simulator. We're going to do some tests together on the resiliency of this application. And then we're going to take the back half of the episode of the hour to see how Q would do it.
Yeah,
and
exactly.
See how much quicker it would be.
So I guess we will do a comparison, and then kind of you can walk away with the conclusions of how, you can start using it going forward. So
this little voting app that we've got, you've got 4 options, and you can let me know in the chat what you'd vote for. You've got Outback Steakhouse, we got Buca de Beppo, we got IHOP, and we got Chipotle.
Well, before I give my opinion, I have not heard of the second one.
That's what I was gonna figure, is that some folks don't know what Buca de Beppo is.
I do not know.
It's an Italian chain restaurant. It's very. You could find it like near like Universal Studios, maybe. It's like one of those like kind of chain restaurants.
Okay, I was gonna say, is it kind of like Oh, we got Chipotle one. Okay. What would you vote, Matt?
Out of these 4, I probably would vote Chipotle. It's probably the place that I would be going the most out of these. So
same, I would be number 3 for Chipotle as well.
I'm gonna seed some votes in here.
Okay.
So we got some random votes for Buca, some random votes for Chipotle, and then a bunch for IHOP.
Oh wow! I mean, I can totally understand Outback, steaks. So
right now, according to our random generation, we have some IHOP folks. I mean, IHOP is a really affordable and pretty good option, especially like you don't think to go there for lunch, and it's pretty good. Not gonna lie. But Outback is winning for some reason in our random generation. This was all a random. I just did random ranges here.
Okay.
But that's what happened. So I'm just seeding these votes in. We're getting some stuff into our application. Can't beat pancakes for everything. Yeah, that's true. I've been getting a lot of ads for IHOP.
I don't know. I feel like I could eat I could eat pancakes for dinner if I really wanted to.
So now that we've got this set up, Zamar, I'm gonna do some monitoring in CloudWatch to make sure that my app is
everything is working as it should. Okay.
So I have a dashboard here, but I'm gonna set up something. So this is something that actually like is super helpful for some of the things that we've been working on Zamara, which is like incident detection and response, where it might not be enough to just like do some infrastructure level monitoring. You might want something that is more application aware. So we're going to create a synthetic canary for our app.
Sounds good.
And if folks don't know what a canary is, let us know in the chat.
So essentially what you want to do is create an alarm to kind of let you know if something is going amiss.
Yeah, and I want it to specifically be trying to hit my application. Because it's one thing to see if the back end infrastructure, like my pods, my nodes, my DynamoDB table, that those are running. It's another thing to actually know if the app is working. Victor, welcome to the show. Thanks for tuning in.
Thank you for joining.
So now I need my my app.
Okay, so you're building the canary. You need the endpoint.
So this is the script that's going to run against my URL. And we got Irietta saying, like a canary in the coal mine. Yes, exactly. Like a canary in the coal mine.
I think we touched upon this subject before. It kind of comes back to me that we kind of discussed this in a past episode.
Canaries in a, it's so morbid. So a couple of things I'm going to do to change from the default. One is I'm going to run this every minute.
Okay.
And then 2, I am going to create a CloudWatch alarm. Okay. So I want to be alerted if it's lower than 90% within 5 minutes. So it's going to check 5 times. And then if it fails within once in those 5 minutes, not good. Okay. And I'm going to create. This is going to take some time, so I will leave it here. Finally, before we dive any deeper, I've got this awesome operational dashboard ready. So this is something that I don't know, like I've been coaching customers a lot on building things like this, where you can make sure how many requests you're getting. You can see all the requests we got in our voting app over here when I loaded in all those votes for
you see the spike going in. Yeah.
You can see that our hosts are healthy across multiple availability zones, because I'm in Ohio. So if we look at our architecture, I'm looking at these AZs, we're not even looking at US West 1. And then here are some metrics in terms of pod CPU utilization, all that stuff. But if we want to really, actually, you can actually see our secondary region here too. If we want to really, what's the word, like get simulate some real traffic, I need to do some load testing. So I'm going to do that with the artillery application.
So I guess like the question here, Matt, the primary region here for the app, it's US East 2, correct? And then the backup sits on the West 1. Okay. And
I'm just going to be doing some like East 1, these 2 specific like in region failures.
Okay.
I'm not going to do any cross region.
So it's not going to be cross region. Okay.
Yeah, and that's we've covered. I feel like we've covered that a lot recently.
Yes, we have. Yeah.
So I am running this artillery. It's going to just create some background load for the application. That way we have some statistics to monitor here, and it'll actually give us a flavor of what this would be like if it was a real in production application.
Okay.
So what do we want to do first? Well, we want to start to simulate failures. And the way we're going to do that is through our friend, the fault injection simulator.
Of course. Let the fun begin.
So we're going to stay outside the console today. We spend a lot of time here at AWS Tech Tales showing you how to build fault injection simulator experiments. So you can tune into our previous episodes for that or do some Googling around. But this is what I'm going to paste this in here. I'm creating a new experiment template that's called pod delete. And so it is, the point of this is to wreck one of our pods.
Okay.
And that way we're simulating this pod failure within a cluster, within a node, kind of going down to the smallest level. And I should just be able to run this experiment and just see what happens.
All right. Let's go for it.
Okay, it's going. So what you can see here is I've executed this experiment. The experiment is initiating. And we've got a cluster that is, oh, here we go.
Okay.
So now we can just watch this kind of play out to see, like, okay, we've got healthy hosts here.
Mm-hmm.
This should continue to refresh, and we should see some hosts fail. So really, like, this is just resilience testing. This is just understanding, okay, what is the failure mode for my application? We're starting at the pod level, and we're going to continue to work our way up to bigger and bigger pieces of the EKS console.
Yeah. Okay, so I don't see anything yet.
Yeah, let's take a look at the fault injection simulator console and see what it's doing.
Okay. Oh.
So it's already completed.
Okay.
So it should have done it.
Let's do. Can we do the refresh?
So it looks like I really am not seeing anything.
Yeah.
Anything happen, and that's because the pod was replaced so quickly
that it didn't catch
that it didn't even show up.
Wow.
Matt, as we deleted a pod, I'm assuming it would be created if it's back. Exactly. So again, this is a great test in that we couldn't even see it happen on our dashboards. It's already been recreated. Okay. So that's a really good, like, +1 to containerizing your application, and 2 +1 to understanding that like if something was to crash, you get another one.
You got like an immediate response.
You're right on, Sam. So that was test 1. Again, these are all now, I have to have built the code to build these experiments. I had to know what experiments to run. So we're going to do 2 more of these, and then we're just going to let the critical thinking go to the AI. So
okay, so what would be the second test that you would do here?
Next, I'm going to delete a node and see what happens. Okay, so I've just got that experiment in there, and I'm going to trigger it.
Okay.
So here we go. So let's go back to experiments. I'm initiating my new experiment.
Mm-hmm.
Let's just see what happens in our dashboards.
I mean, it shows that there is some elevated request, but that's from the voting stats that we did.
This is from our artillery. So this is from right now. This is still running in one of my many terminals right here. It's still running here. So it's still giving me some. So let's see. We've got. Here's our number running pods. This dropped.
It dropped, yes.
To 5. Let's see if this experiment is still. This is completed.
This completed already.
So that's pretty much it. This is the only hit that I got. I went from 6 to 5.
That's it.
And that's it.
Wow. Okay.
So now we can go for the big one. We can go and kill a whole AZ. So, I've got hosts distributed across 3 AZs.
Okay.
That's a good best practice. Let's see what happens.
All right.
Meanwhile, this canary does not like me. Oh, that's why I want to select an existing role. Maybe that's the problem. Hold on. Let's go back to the canary first.
Okay. Oh, the setup of the canary. I see. I see what you're talking about.
Yeah, why did
Okay.
it not work?
What is it telling you?
Oh, created that role. Let's see, refresh. There we go. I have a role. Let's see, create canary.
Oh,
Access
okay.
denied. Let's see if there's anything else that I need to be doing. Let's make sure the script is online. Yep, they're right. It's got my app in there, so that's good.
Mm-hmm.
I'm thinking. Oh, that's probably why. Hold on. Let's go. We want this one. Nope.
Mm-mm.
This is where sometimes we need the chat to help us.
Yeah.
The demo gods don't want to sacrifice a canary. That's a great. They don't want the canary to go to the coal mine. I get it. I get it.
Did you
Let's
check
try.
the script editor?
The script editor is, so I just made sure that, because I just updated this to the right.
Okay.
This looks correct. And then the URL
Yeah, the URL is it
is the right one that I put
is
up
the
there.
syntax good? Like, are we missing something? Probably, because sometimes.
I don't think so.
No, it looks okay. It looks okay. Yeah.
So it might just not like my permissions, which is fine. Okay, well, I'm going to skip ahead on this one then. I'm not going to stress about it. So instead, let's go and do our AZ failure.
All right.
So I'm going to create a new experiment. Again, this would all have been stuff that I would have had to write beforehand, which is build the experiment that's going to terminate the node groups, terminate the node group instances.
We have a question here from Sam. Are we going to run the power interruption experiment template or just the network disrupt action?
So we're actually just going to kill the underlying instances. So that Sam knows their way around FIS. And yeah, power interruption would also be very useful. We're just going to knock these guys out. So let's see what happens when we run this experiment.
Okay.
So it's looking for my alarm.
Is that what? Yeah, because I see it is calling for the.
Okay. It's running. Let's see our experiments running. And we should see
I'm going to
this
go back
drop.
into the dashboard.
There we go.
Okay.
Oh, no, not yet. So we got 2 on each one.
Okay.
We should see.
Still running.
So AZ, it's doing a full AZ failure, SSM. So this should take around 6 minutes.
And if you go back to the dashboard, do we kind of see any movement there? Or we have to wait for it to?
You have to wait for it.
No, yeah, we're going to have to wait for it. Well, in the meantime, does the audience have any questions of we have done so far, what Matt has shown us through?
I mean, this is the manual steps. I'm
This is the
excited
manual
to get to
steps,
the next
yeah.
step.
You think that we'll get through it like super quick?
I don't know. That's where the chat comes in and to help us out.
Maybe some of you have already tried this before. Has anyone had any experience of running this type of tests and see, kind of wondering if someone has already kind of played around with the whole concept?
I think we need to put some waiting music on, right? Let's do. I like this one. So now we're just waiting for our experiment to finish. Oh yeah, where's our experiments? It's still running.
Yeah, it's gonna take some time.
Oh wait, oh, okay, never mind. It just wasn't loading for a second.
It took the excitement right out of you.
But it does say it's going to take about, if we look at the template, around 6 minutes.
Okay.
Where if you look at our previous experiments, it doesn't even have a time associated with it.
Yeah, it was so quick. I mean, it makes sense. It's taking out a whole AZ, so.
So you can see we're using an SSM document. Let's go check out SSM while we're waiting.
Okay.
See, now I have to try to find the name of it before. Let's go back.
It'll be like quicker to run through it.
Still seeing this running. And this is called Simulate AZ outage.
AZ outage test.
Let's go find it. So if you're just joining us, we are doing the last of our 3 experiments to see if we can take down a full AZ of our EKS cluster, see what happens when that occurs. So while we're waiting, we're just digging into what that automation looks like. Let's see if we can find it. Here we go. This is the test. So it tests that our application can withstand availability zone outage while running on the EC2 instance orchestrated by the auto-scaling group. So there's a lot of content in here. That's why it's also taking some time. It's got to understand what's going out there. Looking at the instance IDs. It's ensuring that it's multi-AZ. There's a lot going on. So let's go back to see how our experiment's running. Still running. See if there's any update on our host counts. Got a blip here, but nothing crazy.
What is that one for? This is for, okay, that's a
number of pods.
Yeah, number of pods. I was gonna say how long. When was it? 1724. Okay.
I think we're right around the moment.
Yeah, I mean, it should be now 30. So maybe like in the next minute. It's still running.
Yeah, I don't see it going through. So sometimes
we're just like dealing with our own patience.
No. It's funny because you can see how long these containers have been running, and this is the one that got killed before. So you can see it's only been running for less than 10 minutes.
Yeah.
So, failed.
Uh-oh, what happened?
Action exceeded the specified maximum duration.
So it went beyond the
timed
6
out.
minutes. Yeah.
Yeah. And it might have had to do with me not having the canary built, which is very silly. Because I did call out the call it out in my
I think it did,
config.
because I think that once we were kind of reviewing that step, it was kind of like allocating a 5-minute time period, correct? Like every 5 minutes.
It gave it 6 minutes to roll through.
Okay,
and
so then
it was also looking for that
response
canary
or
alarm name.
Yeah.
So very interesting. Because what I would like to because basically what it's going to do, it was supposed to monitor that canary and what's it called? And then roll back when it failed. But because it's not actually letting me build it.
Yeah, I'm trying to pinpoint to why we're not able to do that one.
It might be just a permissions issue. I'll try one last time, but if not, we can just move on to asking Q to help.
Yeah. Can you maybe check if you switch roles, maybe that would help?
Yeah, we can do that. Let me find the right way to do that. All right, I'm gonna pull this guy over. We're gonna go to Cloud Watch. Application signals, synthetic canaries, create a canary, call it voting app.
Yeah, voting app.
And then I'm going to
you gotta
get my
URL.
So oh, it didn't like that. Am I in the wrong? Hold on, I'll pull it. Give me 1 sec. There we go.
Okay. Yeah, so get that.
We'll leave it at this for now.
Change the script editor.
You want to change it to 5?
Yes, 5.2.
Let's do that.
Yeah.
And then we want to run every 1 minute, and then add the CloudWatch alarm. And that should be it.
Yep.
Let's see if this works. Then we can rerun on our experiment. But I'm giving it, I want to say 6 minutes, and then I want to see what Q can do for the last 20.
Yes, I agree. We definitely want to jump on that one, so.
This is what happens. This happened last week where things were going too smoothly, and then, of course, you always have some sort of issue.
Well, I remember a certain someone. Oh, again.
So it wasn't even my role. Something.
Okay, it's something else. Yeah.
That's okay, guys. So.
Okay.
In general, we killed a pod, we killed a node, we tried to kill an AZ, and it won't let us. So let's talk to Q then.
Let's see what Q can do.
So for some of this to work, I've got a bunch of MCP servers working already that I did beforehand, folks. So if you don't know what an MCP server is, that's the new hot thing. Let us know in the chat if you have any questions about it. But I've got my AWS Knowledge MCP server, my Fault Injection Simulator MCP server. I have my API, my CloudWatch, my EKS, my Chaos Mesh, and my DynamoDB is still loading for whatever reason. I don't know why it's not coming through. So this is all set up.
Okay.
And then the question becomes, what do we want to do?
Yeah, I was going to say, so with all that being already set up, what would be like the next step here?
So I could, let's see, I can bring up the Chaos Mesh dashboards.
Okay.
Let's see if this works. Oh, this will take some time. So while it's doing that, let's start asking Q for some things. And I will turn down the waiting music because we don't have to wait anymore. And if you in the chat want to ask any questions to Q or ask us about Q, please let us know. So first, I'm going to say to Q, help me list the existing experiment templates in FIS in US East 2. So let's just see what it's got. I even misspelled it, and maybe it'll figure it out. Okay. So it's going to say, hey, do you want me to do this? I'm going to trust it. And so it's going to basically list experiments. So it already knows how to like talk to FIS. It already knows what's going on with FIS because we have these NCP servers installed. So this was quick. It told us what you did. We did node deletion, pod delete, and then AZ failure, which didn't work.
Okay.
So then I'm going to say this, but I'm going to copy paste it because I don't feel like typing it all. Please forgive me. Based on the existing pod chaos template, conduct an experiment to shut down 50% of the pods of the voting application in the workshop EKS cluster.
Okay.
So that's a lot of context that it needs to have.
Okay.
So it needs to know what the experiment is. It needs to know that how to shut down 50% of the pods, what my app is, and what cluster it is.
Mm-hmm. So then you have to trust it. Okay. System templates configure.
So it's saying, hey, your template can only kill one pod. I need to make it kill 50% of the pods. And then it gives me some of the updates to this template. So I'm going to say trust. And now it has created the new template. And now let me start the experiment. So now, because it can start an experiment through my FIS MCP server, again, now it's even more smart than normal. I can say, yeah, let's do it. And then we can see what happens.
Okay.
So not only is it starting this, and what I love about Q is that it's saying, here's what we're doing in this experiment. Here's what it does. And then do you want me to like check the status of it? It's running successfully. It's telling us how to monitor. And so now we can take a look at what's going on in our dashboards to see if we've killed any pods.
And so what's interesting here too, and I guess like for me, for example, right, looking at it, it's in that same CLI, you're actually getting like what we were doing before, that we were going to see like if it was running in one part of the console, and when it had finished or completed, we're kind of getting that update within the deployment itself here in the CLI.
Yeah. So you can continue to say check the status. It'll know what you mean. It's thinking.
Oh, is it
completed successfully?
Yeah.
So
you see the timestamps and everything.
So now that we know that it was completed successfully, what we're seeing is that barely blipped us.
Right, and it
Already
was kind of like the same thing that we saw at first, right? We
Mhm.
didn't even see it. We didn't see a reaction in the dashboard itself.
So what's super interesting here is that is now, like, let's say you wanted to do something that new, because before we basically told Q to kill 50%, right? Let's change it.
Okay.
But now you could, let's say, summarize it. So let's say, like, what happened in my accounts? What was going on?
Okay. Help me summarize the 3 experiments. Okay,
So 3 completed, 1 failed. It's checking each of them. It's going to give me a summarization. So if you wanted a report for, like, your management, this might do it for you.
does this also include the recommendations on what to take into account? I would think of like resolutions if you were to run this like in the manual scale.
Well, you could ask it to, for example, like understand how the application is deployed, and to do that, should we try that out?
Yeah, let's try that out.
Okay, so this is a copy paste that I've got. So our workshop EKS cluster you deployed in USEast 2 contains a voting app application. Analyze the complete process of HTTP requests from the client through the ALB to the EKS node and subsequent database in the scenario, including DNS resolution, TCP connection, request processing, and create a comprehensive text-based topology map and provided. I mean, this is like kind of pigeonholing it a little bit into it's breaking down exactly what we want, but I think it will show how powerful this is, especially like if you know your application, but you need a little bit more stuff. So again, I'm going to keep trusting it. So this is so you know that the AI is not going to do anything malicious to you. It's going to tell you exactly what it's going to do, and then.
And it waits for you to agree to do it. So.
But once I hit trust, if it ever asks to do the same thing again, then it'll just happen.
It's just automatic. Okay.
Yeah, I could just so that's why I could use yes or no. So there's a lot of things that it's thinking through, because it's got to go through and understand what the application is. So if you have a tough time giving people topology diagrams or documenting your application that's already in production, I know we run into this a lot.
Yeah.
This might be the solution that you need. And look at all the free time we have back, Samara. It's just doing this stuff. I don't have to run any commands. It's telling you exactly what it's thinking.
All you really got to do is just read through what it wants to do and trusting it so far. So.
But it's also helpful, like what I was saying with Brooke is that like it's telling you what it's doing, so like you still are kind of learning what you should do. Though this is crazy. This is crazy.
Oh,
I haven't
look at
had
the
to do this
diagram. Look at
before.
that.
This is where like the folks that are really
No
good
more
at asking
using like that graphing app to like map everything out.
Yeah, exactly. So now it's saying where are your subnets, where's the ALB. So you could just put this in an email and send it to your friends.
Yeah, that's.
And by your friends, I mean your coworkers. So do not let company give each other people.
Nothing external. This kind of reminds me of like when you're just staring at the printer, like print out your document and just like waiting for it.
Yeah, that's what it's like. That's what it is doing. It is kind of printing in its own special way.
I can hear the sound in my brain, like just registering the action of it printing out.
Like a dot matrix printer.
Yeah. It's like when you see the what is it called? Like how we used to connect in the internet in the early 2000s and you hear like the whole like,
the dial-up modem? Yeah.
Yes. Okay.
Those were fun. So yeah, so we got a full
Oh, look at that.
topology
You got the
diagram.
diagram and description of the diagram each step and how it's conducting everything.
Yeah, so literally you could just run this and give it to your AWS stakeholders and let them help you. But then here's the other thing is that now that it knows everything about this application, we can ask it a bit more stuff. So we can say, based on the architecture analysis, conduct resilience testing, identify and analyze key points and scenarios in this architecture where fault injection would mean, or provide meaningful resilience insights. So again, if you don't know what you should be testing for your specific application, if us talking about pod failure, node failure, maybe it's not applicable, maybe it's a different service, you know, you can do that.
Okay. Running podkill with a Okay, so are you running this other experiment, or what is this, Matt?
Oh, so now I guess it's going to run its own experiments now.
Okay.
Minimal impact test. So it's basically doing exactly what we did manually. We spent all that time coding, all that time building, ideating, and instead it's like, actually, I'm going to keep going. I'm going to do all this stuff for you. Don't even worry.
Don't worry. Just sit back and see the results.
Yeah, and monitor. Make sure you're monitoring.
Yeah.
But it's been pretty steady.
Yeah, there was a little.
So this is healthy host count 1.5, which is interesting. Immediately replaced with new pods. Okay. All right, let's go. Now it's running through resource exhaust. So it's just doing all of it for us.
The CPU
so now it's going to stress our app.
Yeah.
Yep, let's run it. Let it run. So it's doing memory, CPU, stressing. And so sometimes it'll fix its own mistakes.
Yeah, that's what I was looking at, that it was saying something about fixing. I guess, like, was it fixing like a syntax that you provided, or it's itself?
I didn't do anything. It did it itself.
Okay.
It messed itself up.
And then it said, oops, need to.
Yeah,
okay.
Said, oops. So now we're doing bandwidth. Basically, we're just here to push the button and let it do things.
Pretty much. Okay.
So now it's doing infrastructure. Isn't this crazy, Zamora? This is your first time
like
looking at Qt, right?
Yeah, I mean, like, yeah. I mean, I have used it in other areas, but not like this. So this is like pretty interesting because, I mean, what was it like? We were trying to do like the manual things that we did was like 3 of them, wasn't it? And then one of them we kind of had encountered like an issue, but like this one, it's already past the, like, it's been like more than 5 or 6.
Yeah, it just did it. Not only did it do the full experiment, excellent, successful, and it said, here's all the things that you've done. This is a really strong architecture, and gave us a full report, and then it's giving us some resilience recommendations. So,
yeah, so this is exactly what I was talking about. Like, can we use it to generate pretty much like a report of like what are the areas of improvement that you need? And this is exactly what I was talking about. It does that for you.
Yeah. Which is crazy.
It is.
Like, for example, let's try it. We've got 10 minutes. And again, chat, if you have anything that you want us to ask Q for you, please let us know. But I'm saying, I'm asking for a hypothesis, right? This is, give me the steady state. And if 50% of the nodes fail, the response time of the voting app fluctuates by no more than 20%. So like, we're prompting it to say, like, can you validate my thinking on this? which is kind of crazy. Oh, I gotta let it go. It's running prompt understanding. So it needed to understand how to prompt from the core. But now it knows our CloudWatches. It's calling AWS via our API MCP server.
Perfect. Now look at the dashboard configuration.
It knows exactly what the dashboard is. Here's our dashboard. It's looking at the dashboard for us. It's pretty crazy.
And so fast.
Yeah, exactly. The only thing I have to do is keep telling it to trust me.
Let me get the current time and set up the proper time range.
So this also highlights the importance of having some MCP servers set up. But I literally set these up in 2 minutes.
I was going to ask you, so for you that went over the setup, and for the people, the viewers right now that are like, seeing this, how long do you think it would be like the range that they would need to dedicate to have all that set up prior to using it in the way that we've been showcasing it today?
I did it I have the commands ready, so maybe that's a little bit, but I did it in a few minutes.
Okay. So it's not that time consuming either to get it to this state.
Yeah, I'm basically pulling it off GitHub. I'm cloning it, and then I'm essentially running it. And it's just kind of open and ready to go within my terminal. So now, what's it's going through?
It's just going through the different motions. It's getting the details on the instances. Okay. Yeah.
Now it's gonna kill. So it's doing the stuff like automatically. So it's actually running CLI commands. It's running the CLI commands to check itself, its own work. This is the power of agentic AI.
So if we go back to the CloudWatch, if we refresh, what kind of activity are we seeing?
I'm not seeing anything yet.
Yeah.
Which is crazy. And I wonder what it's thinking. So it's checking the node status. It's getting more recent. So it's validating its assumptions. Okay.
Okay. Are we getting some results
now? Yeah.
Okay.
No error rates. We killed 3 of these. And
you have your detailed result analysis, the time impact, the findings, and then your hypothesis
time increased by 216%.
Yeah.
But it happened in a single second, which is interesting. Gradual recovery of baseline within 4 minutes. Oh, these is by a minute, so not second. So within this minute, it was a problem, but then the next minute it wasn't that bad.
Yeah. 0 downtime, significant performance.
So it tells you what to do, what you can improve.
And it gives you like what you can do now and long term. Impressive.
And it basically is a little bit sassy. Saying you're decisively rejected. You're dumb.
You don't know what you're talking about.
Yeah. Okay. Thanks. Thank you, Q. And then let's do one last one.
Yes, I think that we have the time. We are entering the 5-minute window, Matt. So let's see what we can do with those last 5 minutes.
So we're going to create a new experiment, shut down 30% of the nodes, shut down the remaining 50% of the voting app pods after 30 seconds. Now this shouldn't work, and it'll tell us why.
Okay.
Hopefully. And I don't even have to prompt it now because a lot of these actions have already been okayed.
Yeah, because you have already given the go-ahead for them prior to this. So
you can just sit and wait. Tell us what you think about this, chat. We've been rather quiet since Q started cooking. I thought maybe it would perk everyone up a little bit.
Everybody's just amazed beyond words.
We're trying to read the screen as fast as it's thinking.
Yeah, that's what I've been doing. I would kind of like go through like the different updates that he provides and just like the different processes that it's running, and it's pretty remarkable.
It's funny how AI loves emojis and bulleted lists. Okay. Now it's
Yeah, so
gonna try to.
I remember like when we were like a minute ago when we were going through the report, it kind of gave you like that criticality, like exclamation mark and like the warning sign and stuff like that. It's pretty similar to what we see like in Trusted Advisor. So I like that because it kind of gives you that like good UI experience as well. So
Oh, okay.
excellent. I can answer covering. 3 pods were created immediately, and it gives you the pods. And then let me check.
Interesting. I can see that the cluster autoscale is already added a new node.
Oh.
Which is so crazy because like this is
It
where it
expects
gets
it to
really interesting.
fail, but then it's like, but it did on its own. It's talking to itself like we did when we were going through the manual motions.
I know, it's scary, right? But this is where again, like if you know don't know anything about resilience testing, but you know your application, or you don't even know your application, you just know what application you want to test. This did it all for us. It mapped up the application to understand what it was. You say, hey, can you run these failure modes? And now it's giving us the experiment.
Yeah, comprehensive analysis, detailed results.
Yeah, wow, look at that.
Oh, love that.
Here's the emojis again. And it's giving us a comparison with the previous ones.
And this is without us prompting to, like in other scenarios, you usually get like an output and you kind of continue having to like interact with it to get more information beyond what it provides. But this is just kind of like, I know that you're going to want to see this and that and that. And it just kind of gives adding flavors to the cake, I feel like.
Yeah, and what I like here is it's giving. I didn't ask it to do key takeaways or give me a score.
That's what I'm telling you. It's just like I know that you will like this, so I'm gonna just give it to you.
Trained on so much, I'm sure. Okay, so I'm just asking it to troubleshoot in the background, but I think given the amount of time that we've got left, we did it. Like we've successfully tested our app using manual resilience testing, but B showed that you don't have to do any of that. Throw it in the garbage, install Q and get it all done way quicker, and just kind of let it cook.
Yeah, that's true. And then so it maximizes the I guess like the time in which you do these experiments, but then at the same time, it gives you the takeaways and how you can evolve from them as well. So I think it's definitely a very useful and powerful tool. Definitely something that I would recommend checking out.
Yeah, and then again, it's also going to help walk through its own configuration issues, or maybe your configuration issues, and ask you to think what it can fix. So I'll let this thing cook, but I want to thank everyone for joining. So next week we're gonna, I think, finish our journey into QCLI. We're gonna go straight vibe coding. So if you heard the term and you haven't tested it out, we're gonna try to do it together. We're gonna set up some of these MCPs together again. We're gonna try to see what apps we can create just by thinking about what we want, and kind of complete our QCLI journey. So I don't know, Tamar, what did you learn today before we end the show?
What I learned today is that you can definitely ask Q to help you maximize the way that you're just conducting experiments, and you can get a massive amount of data and recommendations by using it. So I think that that's extremely useful. So
yeah, Sam says, thanks guys. Thanks for tuning in, Sam. Thanks for Victor, Sam, schizophrenic web developer, Erie Edits. Thank you all for joining, and we'll see you all next week.
See you all next week.
Same place.
Bye. Take care.